Hypothalamus artificial intelligence. Presence. The history of OPTEX, the optimization expert system. The history of OPTEX is strongly linked to the professional and scientific life of its creator, Jesús María Velásquez-Bermúdez, founder and scientific director of Hypothalamus I. The two stories feed off each other, as the scientist provides the knowledge to develop OPTEX, and OPTEX generates results, sometimes unknown, that impact the scientist's vision. Three companies are linked to this story: PDC Ingeniería, Decisionware, and Hypothalamus I. In 1970, Jesús Velásquez-Bermúdez, at the age of 17, began his career as a computer programmer. In 1973, he developed his first professional optimization model at ALIO, which included a matrix generator for IBM MPS models. The professional life of Velásquez-Bermúdez is divided into 4 periods. From 1975 to 1984, Silicon Valley and Caracas. A time of growth in research and entrepreneurship, supported by the Venezuelan oil bonanza. At 25 years old, Velásquez-Bermúdez founded PDC Engineering, starting his career as an investor in the operations research business. PDC invested 400,000 current dollars in a ModComp Classic 7870 minicomputer, to solve complex math problems. PDC may be the first type of Silicon Valley company in Latam. The main optimization algorithm made at PDC was PDC Primal Dual. A bounded primal dual simplex algorithm, with multi-pricing, base inverse in product form, and handling the functional matrix and compact constraint blocks. Pivot and complement heuristic to accelerate MIP problems. Bender's partitioning and decomposition algorithm, using a variation of the standard primal dual method, to handle Bender's cuts as a dense matrix, and compact matrix generation. By then, PDC Primal Dual might have been competitive at the level of today's SIMPLEX, or Gurobi. Due to Velásquez-Bermúdez chooses an independent professional lifestyle. OPTEX will be the result of praxis, as it will be the artificial intelligence used to solve the complex real-world problems he faced. From 1984 to 1990. The Lost Steps. During this period, Velásquez-Bermúdez did not carry out work in operations research. Third period, from 1990 to 2018, swimming against the current. It's easy to brainstorm ideas out of the box, when you're already out of the box. Return to the world of war. A time of developing survival skills in a hostile world for the development of complex math models. This gives rise to Decisionware, DW, a Colombian company that generates a significant increase in productivity in the art of math modeling. The history of OPTEX. In 1990, OPTEX was created to fulfill the project, Corporate Planning of the Bavaria Industrial System, PCSI. PCSI was a multi-problem model that integrated expansion with month-to-month operation. The multi-level Bender's algorithm was used to break down and speed up the problem solving. SIMPLEX was the basic solver. OPTEX generated a C program, and PCSI was solved in a compact PC. OPTEX is a sophisticated non-commercial AI tool, based on an algebraic database language, that uses structured mathematical modeling, making all OPTEX's mathematical models compatible with each other. OPTEX groups all the elements of a math model into 2 types of components. Basic mathematical definitions, elements that exist autonomously, regardless of whether they belong to a model. Making a simile with molecular structure, equations are molecules, which integrate atomic elements, such as indices, sets, parameters and variables. Advanced concepts allow complex multi-problem models, include problems, set of equations that make up a specific problem, and models, set of problems that make up a specific model. Enterprise-wide optimization system, set of models that a company requires to enterprise optimization. Multi-problem large-scale optimization methodologies. Artificial hypothalamus, it is the evolution of DSSs under Industry 4.0, it is a set of models, which exchange information autonomously, working online, following the connectivity established in the artificial cortex, using distributed optimization. OPTEX supports super large-scale optimization in any industry, using complex algorithms, like cross-decomposition. The OPTEX artificial hippocampus stores, forever, modeled structures. Therefore, a modeler does not have to repeat the job every time he modifies a model. The union or division of models is done by keeping the records in tables, clicking on the algebraic elements, as in a Lego game. OPTEX handles highly complex multi-problem models, by distributing the computation across various platforms. Initially, the OPTEX user interface was a data window to capture the contents of tables. The master index table and its relationships are viewed through a database explorer, and there is no need to investigate through complicated computer programs. Today the data is captured directly from MS Word, and soon it will be from ChatGPT. OPTEX models may use multiple technologies, due to the clear division between math model and computer language. Fulfilling the functions of generative AI, OPTEX generates EWOS on many optimization platforms. OPTEX is at the highest level of optimization technologies, as it relies on AI concepts to produce cognitive robots that integrate the other technologies. Since 1978, Velásquez-Bermúdez has been a scholar of large-scale optimization methodologies. The first version of OPTEX used a version of multi-level Bender's partition. Subsequently, the research has focused on the development of parallel optimization algorithms. This research, and its real-world implementation, has allowed HI to understand the artificial cortex as the map of the artificial hypothalamus process. The state of IT is the integration of edge and cloud computing. So, implementing multi-problem models, solving the math problems in parallel, results in autonomous real-time distributed optimization, on different types of computers. OPTEX is moving towards an artificial intelligence that can solve, online, an executive's question. How much should the company produce of a SKU, in each factory, in each period, and how should transport it to the markets? OPTEX has a different view of mathematical modeling, conventionally based on programs and programmers. OPTEX has completed 34 years of being awesome. From 2017 to the present, creating the Emperor's new artificial mind. In 2017, Velásquez-Bermúdez began to formalize the empirical concepts implemented in OPTEX, to establish a math theory for artificial brains, and thus integrate OPTEX with AI based on neuroscience. This process was consolidated with the creation of HI, a knowledge factory in math modeling, in 2021, at the age of 68. In 2024, HI was awarded by the Industrial Engineering and Operation Management Society, IEM, for its research on artificial intelligence applications in businesses, industries and services. HI won the IEM Society, Artificial Intelligence Award. By the work, Artificial Business Management. The status of HI's investigation can be found in various white papers and videos. The latest video is Algorithms Learning. How do artificial brains learn math? OPTEX. Projects implemented with multi-problem models. To carry out real-world projects, the key factor is to manage an information system of math models, a warehouse, which serves as a basis for the construction of new models. OPTEX includes multi-problem parallel model processing capabilities. It is demonstrated through numerous significant optimization models, much more than 100, that were born in enterprise optimization. The table presents 40 outstanding projects carried out with OPTEX. To participate in the ALIO award, HI selected the project, Pipeline Planning and Scheduling in Eco Patrol, which corresponds to 2 projects carried out 10 years apart. The planning model was contracted by the Colombian Petroleum Institute, 2003, and the programming model by the Vice Presidency of Transport, 2013. Case: Oil Express Pipeline Real-Time Optimization. Eco Patrol will be identified as Oil Express. The white paper, Oil and Gas Artificial Brains, and the video, Pipeline Optimization. Describe the OPTEX implementation. The Oil Express pipeline has 2 pumping stations, PSO1 and PSO2, and an FSO maritime terminal. The pipeline profile is displayed. To ensure the quality of results, it is necessary to connect a pipeline hydraulic numerical simulation model with a hydraulic model in the optimization model. The numerical pipe simulation model, which represents the entire pipe, is essential to ensure the quality of the optimization model. The model in table format is not easy to incorporate into the optimization model. An alternative is to convert the table into a continuous model, using a regression model. These models run offline. The approximate regression continuous simulation model produces energy losses as a function of flow and pressure, for each product and each pipe section. The functions used were polynomial. The pipeline simulation optimization model must be included in the optimization model. HI used approximate linear functions, which speed up the problem-solving process. Convex hull with an optimal surface. HI uses the generation of A to speed up the execution of optimization models. The transport system has two key components, the piping system and the pumping stations. The connection between them is made by the pressure and flow rate at the outlet of the stations, which depend on the batch, product type, being pumped, and the configuration of the pumps, pattern. This is reflected in the structure of the mathematical model, which includes two integrated problems. The problem is mixed, nonlinear, non-convex, with chaotic behavior at certain points, and with disjunctive constraints. Not easy to solve as a monolithic model. HI approach extracts pumping stations equations from the integrated model, to represent them through an optimal surfaces convex hull, generated by solving multiple low complexity problems, for each station, minimizing energy consumption. The convex hull is represented by a grid of points for flow and pressure. Each grid point links the optimal variables that produce the pressure and flow, like energy, cost and operating pattern, including the RPM of the pumps. The points inside the grid are calculated using a convex linear combination of the extreme points of the cell containing the point, this for continuous variables. In the case of discrete variables, like the pattern, the process is a bit more complex. The combination weights are set by the model. Each convex hull point is associated with a pump's operating pattern, and technical operating conditions. The procedure involves for each pumping station, each type of product, and for each point of the grid to solve the pumping station's offline optimization model. On the left are the equations that represent the convex hull in the optimization model. The data is produced offline and download in the expert optimization system. In the mathematical model, the convex hull replaces the constraints of pumping stations, drastically reducing complexity. Structure of the large-scale optimization model. The optimization process has been divided into 3 stages. The offline generation of convex hulls is carried out when new products are incorporated into the pipeline. The first part of online optimization is not parallelizable, since the movement of all batches is intertwined. At the end of the optimization, the adjustment of the station operation is parallelizable. This accelerates the crossover when the number of periods of the planning horizon is large, due to the duration tends to 0. This is typical of optimal control models. All the processed information is stored in the expert system. Case, Oil Express. Real scenario results. OPTEX generates the model to use GAMS. The shell window contains the pumping station's master table, and 4 data windows with relationships. Energy costs depend on pumps. Pumps 2 and 3 use fuel oil, pump 1 uses electricity, whose cost changes hourly. The hourly report shows the status of each pumping station. The hourly pump report contains the status of each pump. The pumping station hourly dispatch report includes crude oil transferred, optimal pattern, and quantity shipped. The hourly pipeline report presents the data for each section. The hourly movement of batches along the pipeline, including volume, is presented. Comparing the results of 2 operational policies, it can be observed. The minimum energy policy generates 16.21% of overcost, and the minimum cost policy generates 19.43% of overconsumption. These differences are not negligible. Nowadays, evaluating them is an environmental commitment of all companies. More than 50 years dedicated to the art of mathematical programming, his research in OPTEX and artificial brains has been funded by him and his own companies, without receiving funding from other organizations. Thank you for your attention.